All right, hello everybody. I decided to do an old school video today without Loom, so that way I could kind of write these calculations down with you guys, because I think a few of you were still struggling when we did specific heat last Friday. So a few things. This is the practice that you are doing today. Pre-AP, you're doing the same practice. You just have some more problems to calculate at the bottom here. So really quick, I wanted to go over, there are two words that I didn't quite explain on this slide. However, outside and inside you should know pretty easily. But really quick, so in Latin, we've talked about some roots in here, but in Latin, that is actually calor or calor. If, for those of you that speak Spanish, calor, what does that mean? Heat, right? So the Latin root for that is calor, or what we see in calorimetry, right? And then for Greek, that would be the only other one, which is therm. What we see for thermo or thermochemistry or whatever, therm. So that'll help you on that slide. This slide should be pretty straightforward. You're dragging these into either exo or endothermic. You will need your notes from yesterday for that. Specific heat, even if you don't really know what this is, guys, it gives you the specific heats, and guys, just put them in order, right? So if mercury has the lowest specific heat, where do you think mercury is gonna go? Mercury is gonna go right there, right? So that's what you're doing on this slide. This one is easy. That's based off our specific heat notes, but I'm about to review that in a second. Same for units, what units go for each of these, right? That would be easy, which brings me to what I wanted to review. So this is gonna be, I'm gonna do slide 7 with you. So this is slide 7. You're actually doing these on your slides, but you're gonna need a separate sheet of paper to help you with these calculations. Let me make sure I have a calculator out here. So remember that our formula that we need to use is Q equals MCAT. And then we have all the rearranged formulas, right? But even if you don't remember those, guess what? They're on the slide, okay? So based on what the slide says, we need to enter the values for each variable here, and then we're gonna put a question mark for the unknown, and then we're gonna circle the correctly solved formula that we would use with this red circle. You're gonna drag the circle onto the right formula. So this problem says, what mass, so right off the bat, what do we know that we're probably calculating? Probably M, right? So we can go ahead and over here, put a question mark for M, okay? So that's that. Then it says, was heated from 25 degrees Celsius. So from, which means that would be our initial temperature or our final temperature. So just like our practice, I recommend doing what we did for our practice. Put our known, what formula are we using, and then our answer, right? So we already know that this is a question mark, C and delta T. So how do I know which is which? The units. So that's where this slide comes into play. So this slide right here, that's why you need to do this correctly. So from our notes, remember that for Q, we need to see joules, right? Just the J, joules. For mass, we need to see grams, G. For Celsius, that's that big one, joules over grams Celsius usually, or it's cals over grams Celsius. For delta T, remember that this delta means change. The triangle means change. And for this, we need to see a degree Celsius, okay? So, with that being said, we are given two temperatures. Remember that, and here we'll put a separate formula over here, that delta T equals TF minus TI. Remember, this means the final temperature minus the initial temperature. What does initial mean? What do we started out with, right? So based on this right here, it says it was heated from 25 degrees Celsius to 75 degrees. So which one is our initial? What did we start with? 25. So we started with 25 degrees Celsius and we ended with 75 degrees Celsius, right? So 75 minus 25, obviously our delta T is 50 degrees. Okay, so this is our delta T. You only need to subtract them though, guys, when they give you two temperatures like this. If they don't give you two temperatures and they only say, this is the temperature change, then you don't need to do this part. Hopefully that helps some of you. Now, and then it says, if 2,200 joules were used. What does joules mean? Or what's the abbreviation for it? J. So if it's only J, not J over gram Celsius, not this, but J, then that would be our Q. So 2,200 J. And then we need the C. What does C stand for? Specific heat. So the specific heat of water, they give it to us, 4.184. So let's just use the whole number that they give us. Okay, so 4.184 joules per gram Celsius. Got it? So that's your first thing, is to identify. You have to read and identify all your known. Like, what do we know from this problem? Then, if I'm solving for M, what problem should, or what formula should I use? Probably the one that says M equals, right? So I'm gonna use this and drag it on top of this formula, because that's the formula I'm gonna use for this, okay? So I'm gonna do, I'm gonna go ahead and write it down here so that way I can like see it. QC times delta T, right? So then we're just gonna plug everything in. So M equals, our Q is 2,200 joules, and we're gonna put that over. Our C is remember, in parentheses, 4.184. Remember that the bottom goes in parentheses in your calculator. 4.184 times our delta T, which is 50. Close parentheses. So remember, parentheses go at the bottom. So this is what's gonna go in our calculator. Now for those of us that have these calculators, you would literally put 2,200 divided by, in parentheses, 4.184 times 50, and close parentheses. So we get 10.5, or you can use the calculator for those of you online that don't have a calculator at home. So you should be using this calculator here. So you would do 2,200, right? Divided by, in parentheses, 4.184 times 50. Close. Enter. You should get the same thing, 10.5. So our answer is going to be 10.5. And then find the answer. But go ahead. That's a good question. So where are we typing the answer then? So here we'll just put equals, because I do want you to obviously put the answer on this, guys. So you're gonna put 10.5 on here. Okay. And you can expand it just like that. All right, so our C was 4.184. And don't worry about the units, guys. I know it can be a pain to write down the fraction on there. Q, 2,200 J. And then temperature, we said, was 50 degrees Celsius, right? Okay. But I want you to also have it on paper, so that way you know how to do this, because if you're just typing in here, guys, you're not learning, right? It's really hard to learn when you can't like actually physically write it down. And so what I want you to do for the answer then is just to put like equals next to the question mark and put your answer here. Sound good, y'all? That's it for that. Oh, these ones ask you to solve. Oh, so for this one, you just have to set it up. It looks like. No, I want you to solve it. Go ahead and find the answer, because it's good practice, and it's only 5 problems for you guys. Pre-AP, I also want you to solve it. I didn't notice that it was just a setup. Anywho, see what's important to read directions, y'all? Anywho, I hope that is a little bit helpful for you all, and just mainly focus on the formulas that you have here. It doesn't look like it's having you solve for delta T at all, but if you do need to solve for delta T, you guys have the formulas. You need to look at your notes. And you're submitting the PDF version of your slides today. File, download, PDF for those that need help. All right, hope that's helpful. Bye.